Hi everyone, it's Mr. C here with your test review. For this video, we're just going to do some math problems for finding pH, pOH, OH, concentration, and all that stuff. So let's do this. I got 7 problems lined up. We're going to start with basic pH. So we're going to find the pH of 0.9 molars of HBr. Well, HBr is special. It's a strong acid. It's on your strong acid list. So I know that the molarity of HBr is going to be the same as the molarity of just the H+. Why? Because it 100% dissociates. So the way I solve this, I just do negative log of my H+ concentration, which is 0.9. And I'm going to do that on my calculator. I get 0.046 is my pH there. Regarding sig figs, just do like 2 sig figs every time or 2 decimal points for pH and you'll be fine. Looking at the next one here, I want the pOH of 0.7 molars of another strong acid. This is another one that is strong. So we know that pH is equal to the negative log of that concentration. So my pH here is negative log of 0.7. which for me is 0.15. However, this is not my pOH, right? To get pOH, I got to do 14 minus my answer on my calculator. I'm not going to round until the very end. So if I do 14 minus answer, I get 13.8. And there you go. 13.85 is fine as well. 13.85 is the pOH of an acid. 14 minus pOH is pH, vice versa. 14 minus pH is equal to pOH. Let's keep going. We're going to find the H+ concentration of a pH 6 solution. So using the equations we have 10 to the negative pH. I'll write that a little better, but on your calculator, it's 10 caret negative pH, so negative 6, and that's just going to be equal to 1 times 10 to the negative 6th. Your calculator might write it as 1e6 or 1e negative 6, which is the same thing as this. Now, whenever you're solving for concentration, you need a unit, so that unit is going to be big M for molars. So this right here is your answer. 1 times 10 to the negative 6 molar. There you go. If I want to find the OH concentration, but I'm given pH, I just have to do one extra step here. So there's 2 ways to solve this problem. I'm going to do the easier version, which is just to get pOH. Here's the thing. If we know that 10 to the negative pH, okay, is equal to concentration of H+, then we also know that 10 to the negative pOH, okay, should also be equal to the concentration of OH minus. So these just come from your equation sheet, and I'm just going to move this down a little bit. Okay, so if we want 10 to the negative pOH, well, first I need pOH. So what's pOH? Whoops, it's going to be equal to 14 minus the pH. So that's just 11. So now I just do 10 caret negative 11, and that's just equal to 1 times 10 to the negative 11th. That's it. So I'm going to bold this. There's your answer, and again, you need units here. This is molars. Now, if you take a look, right, the pH is really low, so you're going to have a high concentration of H compared to your OH, right? Your OH concentration, this is such a tiny number. What's the H+ concentration? It's just 1 times 10 to the negative 3rd in order to make that equal to 1 times 10 to the negative 14th, which is that equation that you see. H times OH equals 1 times 10 to the negative 14th. So that's another way you can do it. Get this first and then do the division, but I think this way is easier. Do the subtraction. Okay. And again, when you have a low pH, it means you're acidic. When you're 7, you're neutral, and when you're high, above 7, you're basic. Let's take a look at this one. Again, same stuff we've been doing. This is a strong base, NaOH. Any metal plus a hydroxide, for the most part, is a strong base. So if I want the pH of this, we start with our negative log of my concentration, which isn't that bad. Negative log of 0.85 is giving me like 0.07. That's a very low pH. Well, now I got to do 14 minus answer, and I'm getting 13.93. And that is my answer. Now, keep in mind, pH does not have units, so you can just leave it like that. It's just the number. You don't need a unit there. Okay, 2 more, and then we're done here. I want the pH of a 1.3 molar solution of calcium hydroxide. Uh-oh, be very careful here. This, too, is going to cause people some issues, all right? All that means is you got to double the base concentration. So if I draw this real quick, I have, right, calcium hydroxide here, and it's going to dissociate. So CaOH2 actually dissociates into, fully dissociating because it's strong, into my calcium. Calcium's a +2 charge, plus, well, I have 2 hydroxides here. So this is 2OH minus. Now, if you remember, we want the negative log of OH minus. So from my mole ratio, if this is 1.3 molars, then OH minus means I have to double it because I have this lovely 2 out front. Uh-oh. So this is 2.6. Yay. So how do I do this problem? Well, all I have to do really is this. Negative log of 2.6. And that gives me my answer. And we got a negative number here. Ouch. And don't forget, pH is allowed to be negative. You can do that. So let me just get rid of this drawing here. You are allowed to have a negative pOH. So what's my last step? Well, I got to do 14 minus answer. Okay, 14 minus answer is actually going to give me a pH value that's bigger than 14. You can do that. You're not going to see it very often, but this pH is 14.41. So there you go. All right, so that's pretty much it for the strong acids and bases. I do have one that I want to go over here with the ice table. I want the pH of 1 molar of HCN. And you'll notice that HCN is not a strong acid. So because of that, we need an ice table. HCN here is going to break up only a little bit. It's going to dissociate a very small percentage. And it's going to break up into my acid, which is H+, plus my CN minus. Now the CN minus here, that's a conjugate base. So I'll make the base blue. CN minus here. Okay. So all you got to really do here is, so 1 molar is your initial concentration. So we're going to make our ice, I-C-E, ice. So 1, I don't have any products when I begin the reaction. My change, well, whatever the change is, we don't know. But whatever that change is going to be how much H plus I have. So we're just going to solve for that change. We're going to solve for X. And when I do my little line here, I get, all right, 1 minus X, X, and X. Now, from your table, you need your Ka value. This is an acid. If it's a base, you need a Kb value. Our Ka value for HCN is 6.6 times 10 to the negative 10th. We're going to set that equal to x squared over 1. My bad. This is 6.2 times 10 to the negative 10th. Okay, so 6.2 e negative 10 on your calculator times 1, so just hit enter, and then take the square root of answer. So square root answer, square root of this, and you get x to be 2.49 times 10 to the negative 5th. Here's the thing, don't round this yet. So I'm just writing this for your benefit, times 10 to the negative 5th. I'm writing this for your benefit. You do not round till the end, because all you got to do now is negative log of answer. So once you have this, you're going to take the negative log of answer and hit enter. So negative log of answer should give you 4.6. So your pH here, after all this work, is 4.6. Now remember, if it's a base, you've got to do 14 minus, but we're an acid, so we're good. We can stop right after we get X and take the negative log. We're good to go. And that is how you get the pH of a weak acid. I hope you enjoyed. Until next time.